Hello, welcome back. In this lecture, we will discuss about phase comparison monopulse tracking radar. The angle of arrival may be determined by comparing the phase difference between signals from two separate antennas. We'll use two antennas and we'll identify the path difference between the two arrival of the two echo signals. Depending upon the path difference, definitely there will be a phase difference. That phase difference will give you the tracking data of the target. And we will neglect the amplitude of two echo signals that are essentially same from each antenna, but the phases are different. We neglect the amplitude variations because both the antennas will be at the almost very near to each other, and because of this the echo power received in two antennas will be almost same. So we neglect the amplitude difference. We consider the phase difference in the two antennas. The measurement of angle of arrival by comparison of the phase relationship in the signals from the separated antennas of a radio interferometer is called interferometer radar or simultaneous phase comparison radar or phase comparison monopulse. If you see this following diagram, you will understand what we are discussing. Consider if this is our target and these two are the antennas separated by a distance d. Now if you see this, if you observe this diagram closely, you can understand this target is close to this antenna 2 than the antenna 1. The distance of the target from antenna 2 is denoted as R2, and the distance of target from antenna 1 is denoted as R1. Now this is the average line, which is representing the distance R. Now this is the angle of the wavefront. The angle of the wavefront is having an angle of theta with the axis of the antennas, axis of both the antennas. Now the distance R2 can be denoted as R2 is equal R1 is equal to R plus this average distance R plus d by 2 sin theta. Now the distance d2, the distance R2 is R minus d by 2 sin theta, because the sin R plus d by 2 sin theta and minus d by 2 sin theta, the difference here is because target is far from R1, we consider plus d by 2 sin theta. Here target is close to antenna 2, so we have considered R minus d by 2 sin theta. And the phase difference between the echo signals in the two antennas is approximately delta phi is equal to 2 pi by lambda d sin theta. We know d and we know the angle theta. So this is the phase difference. For small angles where sin theta is approximately equal to theta, the phase difference is a linear function of angular error and may be used to position the antenna via servo control loop, because both the antennas are very close to each other with a very little separation d. Now the angle of the wavefront theta will be very less. Consider a sine wave where sine 0 is 0, sine of a small angle will be almost equal to 0 itself. So that will be a linear function. If you zoom and see a sine wave with a very little portion, you can consider near to 0, you can consider it as a very linear portion. Now this linear portion is used to position the antenna using a servo control loop. This is how phase comparison is carried out. Phase comparison monopulse is used to detect the to tracking data of monopulse tracking radar. Thank you.